When building SwiftUI animations, there are several ways to specify how the objects in the animation should move. Mainly, you will specify your animation as linear. You can use eased animations for any kind of animation you want to build in SwiftUI. You can use spring animation or use a custom cubic-bezier function. In this video, we look at each of these categories and where to use them for your animations. The categories serve different purposes, so depending on the animation you are building in SwiftUI, they are all useful for specific use cases. Let's begin with linear animations. When you want the beginning and the end of the animation to have the same speed, the category you should go for is linear. As you have noticed here, and also in the circles animations, linear does not conform to laws of motion, so it has a constant speed at the beginning of the animation and also at the end of the animation. There is zero acceleration, so there is no speed up or no slowdown. The beginning of the animation is the same as the end of the animation. If I go back to the circles again, you have noticed the initial speed of the blue circle is the same as its final speed, so there is no change in speed at all. We apply each of the animations in the same way. So for the linear animation, we are using Face Animator to animate the circle with an offset, that is the X offset. For demonstration purpose, we are moving it from this position to this position on the X-axis. So the animation for each of the circles is the same, except the type of movement applied to it. Each of the animations also has the same speed. So once again, for the blue circle, the initial animation speed is the same as the final animation speed. To see a practical application of this, I will bring another animation. In this animation, as the border moves around the view, you have noticed it stops at some point and also start moving again. Let's see what happens if we change the animation type to linear. Over here, you have noticed we have ease out, so all we need to do is to change it to linear. So if I bring the preview again, you have now noticed the stroke is moving with a constant speed. There is no change in speed at all, so it doesn't stop on the way before starting again or slow down. So this is how linear animation works in SwiftUI. You can use this motion type to, for example, animate path properties, like creating a matching ants effect, animating with dash face, or trimming shape paths. Here is a practical example of an animation using linear. In this example, we are using it to create a matching ants effect. With the same matching ants effect, we are using linear to animate the dash face of the heart icon. In this example, you can also use linear to create constant spinning or rotation animation of objects in SwiftUI, like the way the fan symbols animate in this example. For the next animation, we have default. As I told you, it is using the same face animator, and we are animating the offset. The only change is the movement type, so here we have default. This is the default timing function in iOS, visionOS, macOS, and watchOS. It is similar to the easy now timing function and ensures that the timing of your animations match that of most system animations such as iOS, watchOS, macOS, and tvOS. Similar to easing out, it is great for building on-screen animations. So when you use the default curve in SwiftUI, in the beginning the animation slows down, and also at the end of the animation, it will slow down again. So here is a practical example of an animation using the default timing curve. So default is categorized as one of the eased animations because it has acceleration and also deceleration. As you saw from the previous video, at the beginning of the animation, there is a slowdown, and in the center, it increases in speed and also slows down at the end of the animation. Next, we have ease out. If I bring the graph for ease out, you have noticed in this graph, the ease out pacing causes the animation to speed up quickly and slows down as it progresses. So you can use this movement type to move objects onto the screen rather than objects that move away from the screen. In that case, you need to use ease in. So here is a practical example of ease out. In this example, the bell's rotation uses spring animation. However, as it moves into view, it uses ease out, which is more appropriate for moving objects onto the screen. Next, we have easing out. The easing out curve is similar to the default curve you saw previously. So when you look at the circle with default and also the one with easing out, you have noticed they move in a similar way. The easing out pacing causes an animation to begin slowly and accelerate through the middle, and also slows down again before completing the animation. Like the default example, it is great for animating on-screen objects. It is suitable for moving objects across the screen from one point to another point, and also moving one object towards another. For the next example, we have ease in. When you look at the ease in animation closely, you have noticed it begins slowly, but its velocity increases over time. So you can use ease in for auto-initiated animations in SwiftUI. You can also use it for moving objects off the screen. As it begins slowly and its velocity increases over time, it is purposely used for animating objects that require less attention. For example, making an object disappear entirely from the screen. In the next category of animations, we have spring animation. Basically, we have bouncy, snappy, and smooth. You can also create some advanced spring animations, but we are not covering that in this video. We are only using the default spring presets: bouncy, snappy, and smooth. You can customize a bouncy spring to create a follow-through or cascading animations, like what is shown in this example. So if you want to create a follow-through animation whereby the objects have imprecise motion, you can customize a bouncy spring to achieve that. In our example, to customize the spring, you can use duration and extra bounce. So let's bring parentheses here and add extra bounce. For example, we'll set this to 0.3 and see what happens. You have noticed for the first orange circle, we create a more bouncy effect. We can also change it to, for example, 0.5. And that becomes even more bouncier. I'll change it back. If you want an animation to feel more snappier, you can customize the default snappy preset like we did in the bouncy example. You can do the same thing for the smooth preset. From iOS 17, when we add animation in SwiftUI using with animation, without customizing the animation further, you get a smooth movement like what is seen here. That is across all Apple platforms like iOS, visionOS, watchOS, macOS, and tvOS. Aside from using these standard types of animations in SwiftUI, that is linear animation, eased animations, and spring animations, you can also add a custom timing curve. To add a custom timing curve to your SwiftUI animation, the best place to go to is easings.net. Over here, they have different kinds of timing curves. You can just click any of these examples and copy the cubic-bezier values for your animations. The SwiftUI example for the circle is using this one, ease in out back. You have noticed over here, this is for CSS. So for SwiftUI animation, all you need to do is to copy the cubic-bezier values. I can copy this one and go back to Xcode. I will scroll down and go to the section that has the custom timing curve. So instead of using ease in out, ease out, or spring animation for the animation, all you need to do is to use the timing curve modifier. So if I remove everything here and put a period and type timing curve, you have noticed we have three types. You can specify the one with curve and duration. We have the one with only points and also points and duration. So I can select any one of them and delete everything here and then replace it with the points I have in the clipboard. So this is the same example from the easings.net website. With this example, there is an anticipation. So at the beginning of the animation, you have seen the object moves back before continuing the actual movement. So the same thing is happening in the SwiftUI animation. The circle moves back before proceeding to the right, and when coming to the left, it also moves to the right a little bit before proceeding to the left. Let's also change the speed to have the same speed as the other examples. So I will put 0.2. Now you see it more clearly. So these are the different types of movement you can use in SwiftUI for your animations. You can use linear, eased animations, spring animation, or a custom cubic-bezier function for your SwiftUI animation.